Each chapter starts off with a 1 or 2 paragraph explanation about what the chapter's about. That's what section 1.1 is. Feel free to read it if you'd like. So we're going to go ahead and dive into section 1.2, the nature of data. First chapter primarily covers some important terminology that we'll be using throughout the remainder of the year. First important vocab rule, population. When we're talking about a population, we're talking about the complete collection of all elements to be studied. Think of the population of the United States. We mean everyone who lives in the United States. When we take a census, we want to collect data from every member of the population. The government tries to do this with the United States. They try to reach every member, every citizen of the United States every 10 years and complete the census. Okay, and when we get a number that's associated with a whole population, that's called a parameter. An example of this would be something like 77% of the 3,250 walk buttons in New York City do not work. This is a parameter because we're talking about all of the walk buttons in New York City. That makes that a population. Now this next slide is about a sample, and a sample is a sub-collection of members of a population. In other words, it's just a part of the whole. Population is everyone, a sample is just a part of a population. Anytime we collect a sample, we want to make sure we do it appropriately. Most importantly, we want to make sure our sample is collected randomly to avoid any biases that might arise. Okay, when we get a number associated with a sample, that's called a statistic instead of a parameter, which is what it was called on the last slide when it was associated with everyone with a population. Okay, for example, Nielsen Television contacts 4,000 households to determine the proportion of households tuned into the Academy Awards. In this case, we're talking about just a part of the whole. We're not talking about all of the households, all of the televisions. We're just talking about a portion of them. That makes this a statistic instead of a parameter. Here we have some practice problems identifying these as either parameters or statistics. 22% of high school South students are seniors. We're talking about all South students, 22% of them are seniors. That makes this a parameter. 45% of 877 surveyed executives would not hire someone with a typographic error on their job application. We're not talking about all the surveyed executives, just part of them. This becomes a statistic. 70% of 100 surveyed Toms River School District teachers are cooler than you. That's a fact. But this is also a statistic because we're not talking about all the teachers, just 100 of them that were surveyed. And then lastly, 87% of students in the Toms River School District that took the 2018 AP Statistics exam scored a 3 or higher. Okay, this is all of the students. That makes this a parameter. Types of data should be familiar from your summer assignment. First type of data is qualitative, also known as categorical data. This is the type of data that can be separated into categories. It's non-numerical. In other words, hair color, eye color, genders, favorite sports team, etc. Okay, the other is quantitative data. In this case, we have quantities. This is numerical data, such as your height, your weight, the number of siblings you have, etc. All right, categorical or quantitative, heights of supermodels. Okay, this would be quantitative because heights are numerical. The yield in pounds of a cherry tree, also we're talking about something that's measured, that's going to be quantitative. The birth states of United States senators. Here the answer would be states. These are categories. Okay, it's not a numeric answer, categorical, okay, or qualitative. Number of touchdowns scored by the hitting Indians. Again, this is a number, quantitative. And lastly, eye colors of everyone in the room, categorical, categories, non-numerical. Once we've identified a variable as quantitative, we can further classify it into one of two types. The first is discrete data, which is more commonly known as a countable number, but more specifically, it has gaps separating the values. Okay, some examples are the number of touchdowns that can be scored in the games. In a football game, the number of siblings you have. You can score 1 touchdown, 2, 3, same thing with the number of siblings, but you can't score 1.35 or have 2.17 siblings. Compare that with continuous data, which covers a range of continuous uninterrupted values that doesn't have any gaps or jumps in it. Consider the height of a cherry tree, volume in a cup of water. If we look at a tree, it can be 10 feet, it can be 11 feet, it can be anything in between that. And in fact, if we look at how the tree grows, it will occupy all those heights in between 10 and 11 feet as it grows taller. Here are a few examples. Heights of supermodels, they could be 5'10", they could be 5'11". They don't immediately grow that inch. They could be every value in between. This is a continuous value. The yield in pounds of a cherry tree, same thing, 1 pound, 2 pounds, or everything in between, also continuous. The birth year of United States senators, 1960 or 1961, but not 1960.5. This is discrete. Number of touchdowns, we touched on this on the slide. This is discrete because you can score 0, 1, 2, 3, but not a decimal. Cost of a statistics test book, this is a bit tricky. This is actually discrete because it could be $30.01, $30.02, but it can't be $30.01.37295. All right, so it's still discrete because there's gaps in between those pennies. Last thing covered in this section are the 4 levels of measurement. Key way to remember this is the acronym NOIR or NOIR. So the N stands for nominal. This is just categorical or qualitative data. Data consists of names, labels, or categories. It's non-numerical, yes, no, undecided, colors, etc. The O is ordinal. This is often still categorical, but there's some kind of order to the data, okay? Where we would number them in a way like rankings, first, second, third, maybe tallest to shortest, letter grades in a class, those types of things. But the numerical differences between those differences are pretty much meaningless. You wouldn't subtract like an A from a B or a second place from first place, etc. These next two are really similar and they're a bit confusing. So I'm going to click all these out right now. So it's the I is for interval and the R is for ratio. They're both quantitative, and the difference is that in interval, there's no natural zero starting point. In ratio, there is a natural zero starting point. Thought of another way, in interval, it's possible to have negative values. So if you think about temperatures or years, it's possible to have negative temperatures. Years, even though we don't write them with negative values, it's possible to go below year 0 and into the like BC years. With ratio, the ratio level of measurement, it's not possible to have negative values. So weights, you can't weigh a negative value. Something can't be negative 3 inches long. All right, so that's how you differentiate the two. Think about whether they can take on a negative value. All right, so when we classify these, birth order of 3 siblings. This has data that's categorical, but we can order them. So this is ordinal. Your middle name, all right, this has no order and it's categorical, so this is a nominal level of measurement. Average temperature in Antarctica, this is quantitative. Temperatures can go negative, so this is an interval level of measurement. The weight of a John, weights can't be negative, this would be ratio. Cost of a new car, you wouldn't pay a negative amount for a new car, so this is also ratio.